Hello everyone, welcome to my YouTube channel. I'm Vinay B. Caston Professor, EEE Department, University of Technology, World in Mangalore. So here I come with a new chapter that is Synchronous Generator. We can also call it as Alternator. That is a three-phase synchronous generator. So in my previous videos, I was explained about DC machine. So that will be having DC motor and DC generator. A small difference between synchronous generator and DC generator is that this synchronous generator is it is AC device. You can also say it as in this case here the synchronous generator, it generates AC supply. It generates alternating current, so that we can also call this as AC generator. And the difference between DC generator and AC generator is that according to construction. The difference between DC and AC is that in case of DC machine, as I told, there are two important constructional part in a machine. One is a stationary part, we can call it as a stator. Other one is a rotating part, we can say it as a rotor. So in case of DC generator, stationary part is a field winding, and rotating part we can say it as armature winding. So the difference is that here in case of AC machine also there are two constructional part. One is a stationary part you can see here, and other one is a rotating part, say it as a rotor. But in case of this AC machine, stationary part is nothing but we can say it as armature winding as a stator, and field winding act as rotor. Field winding act as rotor. And this synchronous generator which works on the principle of electromagnetism, which means that when a conductor experiences changing magnetic field, an EMF is induced in it. So here the field winding, that is the rotor which has a field winding, it produces EMF, sorry, it produces a magnetic field, whereas a stationary winding, say it as armature winding in case of synchronous generator, it induces a EMF. Okay, so here a machine which has two parts, as I told, one is a stationary part, other one is rotor parts. So in case of this synchronous generator, so these generators are used for generating AC voltages, hence these are also called as alternators. The the other name will be alternator. So in this case, the synchronous generators or alternators generate alternating voltage at constant frequency when runs at a constant speed, so that the speed at which they run is called synchronous speed, and this alternators generates high voltage, usually 11 kV, so that you can call this as a three-phase synchronous generator, or else you can say it as alternators. So advantages of rotating field over rotating armature, as I told, in case of synchronous generator, a field winding which will be act as rotor, whereas uh, the armature winding which will be act as a stator. So due to these, the advantages is that the first advantage is the generated voltage can be directly connected to the load, so that a load current need not pass through brush contacts. So here you can say it as in case of synchronous generator, there is no brush. There is no brush and there is no commutator, because it directly generates AC voltage, so that here the generated voltage can be directly connected to the load, so that load current need not pass through the brush contact. Directly it generates AC. And the second advantage is that it is easily to insulate the stationary armature for high AC generated voltages. So in case of this generator, we can generate high voltages in terms of kilovolts, that is 11 kilovolts to 33 kilovolts, so that it is easily to insulate the stationary armature. Here stator is armature, so that it can do easy insulation for high voltage generation, and the sliding contacts can be easily insulated, so that the excitation voltage only in the order of 110 volts to 220 volts DC. That is nothing but here to excite the field winding, that is to excite the rotor, will be applying the external DC supply in order to be having 110 volts to 220 volts DC. So here we'll be going to excite the field winding, that is a rotor. Rotor will be going to excite with the help of external DC supply, so that the DC voltage which has a range from 110 volts to 220 volts DC. And the last is rotating field, that is it will be if you are keeping a field winding as a rotor, which makes overall construction very simple, and these are the advantages of rotating field over rotating armature. Next, we're going to discuss about types of synchronous generator, that is based on the constructional details of synchronous generator. So here the construction details of synchronous generator, as I told here also, this is a generator or machine. It has two parts. One is a stationary part, the one is a rotating part. So here the stationary part, which you can say it as a stator, can you are seeing the diagram of stator. So this is a constructional details of stator. Here the stator of synchronous machine is a stationary armature. So you can see here armature windings. So here the armature windings are constants. It will be not rotating, so that the stationary armature, it consists of a core and slots. It consists of a core, you can see here this is nothing but core. So it consists of core and slots. You are seeing the slots here, I think you're following. So it will be having slots and core. So why it is having slots and core? To hold the armature winding. You can see here these are the armature conductors. So to join these armature conductors, also you can see here. So to hold these armature conductors, it will be having slots and core, like the armature of DC generator. And also the stator core of alternator is laminated, and these windings are laminated. The stator core is laminated. This is a core, okay, you are seeing here. So this is a core. The core is laminated. The stator core is laminated to reduce it from the eddy current losses. And here the material used for armature core, that is material used for the stator core. Here stator is armature, so that I can say it as armature core. Material used for this armature core is silicon steel. Why using silicon steel material here? To reduce it from the hysteresis loss, or else to minimize the hysteresis loss, will be using the silicon steel as armature core. And also here the core has slots. The core has slots in its periphery for housing the armature conductors. So core will be having those slots in its periphery to hold these armature conductors. You are seeing the armature conductors. To house these armature conductors, the slots will be placed its periphery. So this is about the stationary part of alternator. Also you can say it as a stator. In case of rotor, so before going to that, just look at the points. The first point is that stator of synchronous machine is stationary armature, and also it consists of core and slots to hold the armature winding, like the armature of DC generator. And the stator core of alternator is laminated to reduce eddy current losses. Silicon steel is used as armature core to minimize hysteresis losses, and the core has slots on its periphery for housing the armature conductors. This is about stator. So coming for the rotor, there are two types of rotor. One is a salient pole type of rotor, the one is non-salient pole type of rotor. So here the first type of rotor is a salient pole type of rotor, also you can say it as projected pole type of rotor. So here the salient pole type of rotor is also called as projected pole type, as all the poles are projected as all the poles are projected out from the surface of the rotor. So this is the surface of the rotor, and here all the poles which will be projected outside from the rotor, so that we can call it as projected pole type of rotor. And this type of rotor which will be used in low and medium speed alternators. A salient pole type of rotor will be used for low and medium speed alternators that will be having in the range of 300 to 600 rpm. And also this type of rotor has a large number of projecting poles you are seeing here. So it will be having a large number of projecting poles. So these are the large number of projecting poles where they are fixed this project these poles. So these poles having their cores, the pole will be having two types. One is a pole core, so this will be the pole core, and the other part is a pole shoe. Okay, so that here this type of rotor has large number of projecting poles. You will be seeing alternative north and south poles having their cores bolted. So this core, it is bolted to heavy magnetic wheel. Core is bolted to this heavy magnetic wheel. See here the bolts they will be using. The core of the that is a pole core which will be bolted to a heavy magnetic wheel that will be made up of cast iron or steel. So this magnetic wheel which is made up of cast iron or steel, and these rotors have large diameter and short axial length. So here the poles which are laminated to reduce it from eddy current losses. So points to remember. So the first point is it is also called as a projected pole type of rotor, as the poles are projected outside from the surface of rotor. And second point is that this type of rotor is used in low and medium speed alternators that will be having in the range of 300 to 600 rpm. And third type is this type of rotor has a large number of projecting poles having their cores bolted to heavy magnetic wheel of cast iron or steel, and these rotors have large diameter and short axial length. And also last point is that the poles which are laminated to reduce it from eddy current losses. And the next type of rotor is non-salient pole or else smooth cylindrical type rotor. So in this case of smooth cylindrical type rotor, it is also called as a non-salient type or non-projected pole type, also round rotor construction. You'll be seeing here the non-salient pole type of rotor, the diagram, and here the rotor consists of steel laminations. So this rotor which consists of steel laminations which are insulated from each other. So this rotor will be consist of steel laminations and which are insulated from each other and pressed together to form a core. Insulated and pressed together to form a cylindrical core which is having a number of slots on its periphery. Why we'll be using this number of slots? To accommodate or else to place the field coil. To place the field coils which will be having a number of slots, so that the rotor consists of steel laminations which are insulated from each other and pressed together to form a cylindrical core having number of slots to place the field coil. So these rotors have a small diameters and a large axial lengths, and the main advantage of this type of rotor is that these are mechanically very strong and thus referred for high speed alternators that would be having the range between 1500 rpm to 3000 rpm. Such high-speed alternators are called as turbo alternators. And this is about the constructional details of synchronous generator or else alternator. There are two main constructional parts. One is a stationary part, we can say it as stator, that is armature winding, and the one is a rotating part, that will be a rotor. We'll be having two types of rotor. One is silent pole type of rotor, the one is smooth cylindrical type rotor. So let us see the difference between these two. So here in case of silent pole type of rotor, poles are projected outside the surface. Here, unslotted portion of the cylindrical act as poles, hence poles are non-projecting. Here, poles are projected in case of cylindrical pole, sorry, salient pole. In case of cylindrical, poles are not projected. And in case of salient pole type, air gap is non-uniform, as you just saw the diagram. Air gap between a pole shoe and pole core and in between armature and field winding will be not uniform. In case of smooth cylindrical, air gap is uniform. And also in case of salient pole, diameter is high, axial length is low. Here it is vice versa, small diameter and large axial length. And the salient pole type of rotor is mechanically weak, and here in case of smooth cylindrical it will be mechanically robust. And the salient pole be preferred for low and medium speed, in case of smooth cylindrical preferred for high speed alternators. And the salient pole type of rotor will be having, in here will be using prime mover as a input. That will be prime movers will be used as, that is a mechanical input will be used as water turbines or IC engines. In case of smooth cylindrical type of synchronous generator, the input will be used as a motor only, that is electric motors or else steam turbines. So these are about difference between salient pole type and smooth cylindrical type rotor.